Today we're demonstrating how calcium chloride reacts with sodium alginate to form a gel using ionic cross-linking. This is how the biobubble will be made before being placed in cavities next to the prosthetic implants.
Here are the materials we used. For the sodium alginate, we pre-mixed and dyed 3 different concentrations so we can clearly compare their textures and diffusion rates. The blue pigment added to each mixture represents antibiotics that would be loaded into the biobubble. For these solutions, we used 5 grams of sodium alginate in 350 milliliters of water for a 1% solution, 5 grams in 250 milliliters for a 2% solution, and 5 grams in 150 milliliters for a 3% solution. We start by making our calcium chloride solution. We're using 6 grams of calcium chloride dissolved into 600 milliliters of water, which gives us a 1% calcium chloride solution. Once it's fully dissolved, this solution is ready to act as our cross-linking bath.
We're starting with the 1% sodium alginate. You can see right away this is the runniest, as it spreads easily and is the most fragile. We scoop it into a circular mold and then submerge it into the calcium chloride solution for about 5 seconds. After that, we gently shake it out of the mold. It does hold together, but this gel is definitely the softest and most delicate.
Next is the 2% sodium alginate. This one has a noticeably thicker texture, it is easier to scoop, and it holds its shape better. After the same 5-second submersion, it comes out smoothly and feels more stable than the 1% biobubble.
Finally, we have the 3% sodium alginate. This is the thickest solution and the easiest to work with. It comes out of the mold cleanly and holds its shape the best. Even though all 3 biobubbles were submerged for the same amount of time, their textures are very different.
One important thing to note is that while increasing the sodium alginate concentration makes the gel thicker and stronger, it also affects diffusion.
This is what the gel looks like 7 days after we made them. We observed rings of pigment forming around each gel, which means that the antibiotics are diffusing out of the gel.
The lower concentration gels diffused more easily, creating wider pigment rings, while the higher concentration gel diffused more slowly, producing a tighter, more confined ring as indicated by these red bars.
So even though the 3% gel is the strongest and easiest to handle, it also restricts diffusion more than the lower concentrations.
And that's how the biobubble is made. Sodium alginate is cross-linked in calcium chloride to create a gel structure suitable for placement around prosthetic implants. Thank you.